This is again a video on information as we can see, the idea or notion of data compression and data error detection and correction are very related. In this video I look at two techniques, both of which can be regarded either as data compression techniques or data error detection and correction techniques. The first one is a very simple one. Now our objective is to code a value, say k, which is less than m equal to 2 power L dash as a value v which is less than s equal to 2 power L, where L dash is much larger than L. Let L dash is equal to n times L. Okay? N is the ratio of the largest piece of information to the smaller sized code which losslessly contains that information. In this technique, it's a very simple one. You can pretty much willy-nilly, you can keep coming up with these techniques, any number of them in fact. Endless number of techniques. One simple one is to use an arithmetic progression. If the ith bit is 1, add a plus a power x here only for the base, but that is, we assume a certain exponent x and a base which is an arithmetic progression. That is, we have a power x, comma, the sequence is a plus d whole power x, comma, a plus 2d whole power x, and so on up to a plus L dash minus 1 times d whole power x, right? Now we would like the sum of the previous terms to be slightly less than the next term, or if the difference is slightly more also, it doesn't affect much, even though it doesn't grow the size of the code very much. Okay. Now we have to check, so that means if for the ith bit the value is a plus id, if we have a plus id whole power x must be greater than a power x plus a plus d whole power x plus a plus 2d whole power x, and so on up to a plus I minus 1 into d whole power x, right? There's one way to do this by reasoning inductively. That is, if we assume that this fact is true for all values of I or j something which is less than I, that means sum of all of this up to the preceding term to this is still less than a plus I minus 1 into d. Then that means we can substitute for this preceding term the value a plus I minus 1 into d power x, so that we try to see if it still maintains the inequality. That is a plus id whole power x greater than 2 times a plus I minus 1 into d whole power x, takes the xth root of this, and you will obtain a plus id must be greater than 2 power 1 by x times a plus I minus 1 into d. Okay, so this is what we get. In other words, we require a plus id by a plus I minus 1 times d is greater than 2 power 1 by x. Taking the binary log on both sides, what do we get? We get log to the base 2 of 1 plus d by a plus I minus 1 into d must be greater than 1 by x. In other words, x must be greater than 1 by binary log of 1 plus d by a plus. As you can see, this value of d by a plus I minus 1 into d will be a value which lies between 1 and 2. If you are taking the binary log of a value which lies between 1 and 2, it will come out to be a slightly fractional quantity, right? So this will be some small integers. So here this ratio should be as small as possible. So we can assume here simply L dash, right? Yeah. Since m is equal to s power n, okay, therefore we can assume x to be nothing but n. So given a value of L dash and n, we can assume x is equal to nothing but n. We can determine parameters a and d such that n is slightly greater than, right? That is, n is slightly greater than in other words, n is equal to slightly or 1 more than 1. N is nothing but n is equal to ceiling of log to the base 2 of 1 plus d by a plus L dash times d. So we determine, given a value for L dash and n, we can determine parameters a and d such that n equal to ceiling of this satisfies. This may not be too large compared to the length of in bits of this, the values of a and d need not be too large either. So you just have to determine this and simply take the sum, and the sum of the previous terms will still add up to a value which is less than the value added to the next one. So the seeming truth of it, so there is no that you can do this really easily. Another way of obtaining a data compression, which is more for the purpose of, which is also possible, is if you have L bits there, right? If you have L dash bits here, some kind of a sum which can still also be used to check and to correct the value. You have L dash bits here, bit 0 onwards up to the L dash minus 1th bit here. You could, to a reasonable extent, you can do it with, choose a small value r such that and take all r combinations of this, and then you'll have an r bit number. So you have a table of 2 per r values, right? You can keep a count of for each how many of these, how many times each value has occurred. Okay. So the R need not be too small, too large. For a very small free file, something like 6 or 8 itself is sufficient. That means 256 parts. Each part is nothing but an 8-bit selection of the L dash bits. And the count of number of times each of these 2 per R values has occurred. Okay. And also maybe the sum of the total sum of this. So the values, once this part is also transmitted, if this is not an error, this value must add up to this sum. So something like this, you can, simple ideas you can come up with. They will tend to be very highly effective. Most of this can be used for data compression also and for error detection and correction also.